Hello everyone, welcome to LetCon. This video builds directly on top of my previous video where we implemented the SPSC queue in C++. If you haven't watched that video, pause this video and go watch that one first. Link is in the description below. So in this video, we'll talk about what went wrong in the previous video. We saw that we were getting garbage data and were losing the updates. So let's start. Let's start by looking at the execution of the producer consumer enqueuing dequeuing and how the CPU reordering works. On the left, we have the producer core in green, and on the right, we have the consumer core in the blue, and we have the shared RAM. Notice on our initial state, the queue is empty because head equals 10, but crucially, look at the buffer 0th index. It holds the value 10. That's the stale data from the previous run, or garbage we shouldn't be reading again. Let's kick off the producer. It wants to enqueue the value 99. Look at the code on the left. The buffer tail is 99, the CPU executes this, but here is the catch. It doesn't hit the RAM instantly. It sits in the producer store buffer, that blue box, waiting for cache coherency. Next line, tail equals to next. The producer needs to update the tail index to signal that data is ready. Look at the pipeline visual. The tail update is queued up behind the data write. In a simple world, they would execute in the order. But CPUs aren't simple. They do some CPU reordering for optimization. The CPU notices that the address of tail and the buffer are completely independent. To optimize performance, it decides to reorder them. If you see that, that's the bug. The tail update jumped into the fast lane, completely bypassing the stale data write. This is the moment of failure. Look at the shared RAM. The global tail is now 1. To the rest of the system, this signals new data is ready. But look at the buffer 0. The data is still the old 10. The signal arrived before the payload. The memory state is inconsistent. Now the consumer core on the right wakes up. It checks, is head equal to tail? No, tail is 1, head is 0. The consumer thinks, great, data is ready. It executes the read. But because the producer's 99, it's still stuck in private buffer on the other core. The consumer read what is actually in RAM. It reads 10. We have just processed a duplicate value. The consumer has no idea, it just read garbage. The consumer finishes its job and advances the head index, thinking it succeeded. Finally, milliseconds later, the producer's store buffer flushes. The value 99 overwrites the slot in RAM, but it's too late. The head pointer has already moved past the slot. That 99 will never be read. This is the lost data. So as you can see, simply relying on int variables isn't enough. The hardware doesn't guarantee the order you see in your source code. It all happens in memory. How do we fix this? Well, there are two ways. In the next video, we are going to take the heavy hammer approach and fixing this using mutexes and locks to force a synchronization. And then in the later video, we'll finally achieve true synchronization using the atomics to prevent reordering without using lock, creating a true lock-free queue. Make sure you are subscribed so you don't miss any updates. See you in the next one.